Over some more of these ones where I give you the reactants or the neutralization reaction, and you tell me what the products are. So I'm just going to do a couple of them, and then I'm going to give you a worksheet where you do more of those. So we'll call this predicting the products. Alright, so I'm just going to do a few examples. These will basically be like the reactions that we were looking at on yesterday's worksheet. We'll start with, what do I want to do here? Let's do something like this. Let's do, there's a 17. I thought we'd do hydrochloric acid and calcium hydroxide. So, the question is, what are the products going to be when these things react? And now we know there's going to be two of them. And you should look at this, and you should be able to tell that the hydrogen from the acid and the hydroxides here are going to come together and they're going to make water, right? H2O.
Calcium chloride.
It's going to be calcium chloride. The question is, what's the formula there?
CaCl.
Okay, is he right? It's actually going to be CaCl2. Well, why is it going to be that? Why? Yes.
Because you didn't use the little 2 next to.
Yeah. So what happens is, if we look at this, right, what's the charge of a calcium ion? Well, right? All right, so what's the charge of calcium? 2. It's plus 2, right? Ca is plus 2, right? We know it because if we look at this, why does calcium get 2 hydroxides? Because it's plus 2, so it has to have 2. And what's the charge of a chloride ion? -1, right? These ones you should be able to tell two ways. And one's by looking at the periodic table, right? Everything in group 2, these are all plus 2 charges, right? Right up there. And then everything in group 17 are all -1. So if we're going to put these together to make something called calcium chloride, well, calcium is a plus 2, we're going to have to put 2 chlorines with it. That makes sense, right? We did this a while ago. We haven't looked at it in a while. So we're going to need 2 of these to go with 1 of these. Right, so that's why it's CaCl2. Does that make sense? All right. And if it helps you, you can write all the things at the bottom here, and then decide what to do with the charges. C225. Let's do. What are we going to do here? Let's do nitric acid, HNO3, plus aluminum hydroxide. How many hydroxides are going to go in aluminum hydroxide?
Wait, good.
How many hydroxides are going to go in aluminum hydroxide?
2.
It's going to be 3, right? Why is it 3? Yeah, if you look at your periodic table, aluminum has a plus 3 charge. So if you're going to make aluminum hydroxide, it's going to be AlOH3. All right, and this is going to produce 2 things. One of them is going to be H2O. So let me break all this down into separate ions, right? My nitric acid is going to separate into hydrogen and NO3, nitrate, right? 2 separate ions. And my aluminum hydroxide is going to break down into aluminum and hydroxide, right? Okay, so those are the 4 ions here. These 2 we don't worry about. These 2 are going to come together and make water, the hydrogen and hydroxide. So it's only the other 2 we've got to look at, aluminum and nitrate. So how many aluminum are you going to have and how many nitrates am I going to have? Yeah, I'm going to have 1 aluminum And I'm gonna have 3 nitrates go along with it, right? Because this is +3, so I gotta have 3 of these things that are -1. Does this make sense? How many people are with me so far? How many people have no idea what's going on? All right, so remember a long time ago, we said when we're writing these formulas for things, charges have to add up to 0, right? So if I have aluminum and it's +3, and I have a nitrate, this minus means -1, right? How many of these do I need? I have to have 3 of these things to go with one of these, so that they all add up to 0. You cancel out the charge.
But where are you getting the plus and minus 3 and like 1?
Where am I getting them from? Nitrate on page 257, if you look it up, it says -1. Aluminum, you look on the periodic table, it's in group 13, it's +3. Also, if you look at these, right, if an acid has 1 hydrogen, then this thing must be -1, because the hydrogen's +1. So it kind of adds up, right? So you can just look at the acid and tell. If the acid has 2 hydrogens, then the anion is -2. So, 3 of these have to go with one of these. So that's how it has to work. I left myself very little space. So it's going to be aluminum, and then 3 nitrates. So I got to put in parentheses and put 3 out there.
Is it plus H2O?
Plus H2O. All right. One more? Yeah. Okay. How about, let's do sulfuric acid, H2SO4. Before I even continue, SO4, what's the charge going to be? It's going to be -2, right? Because it's got 2 hydrogens with it. So this thing here is going to end up being -2. You don't even have to look it up, because you know if it's got 2 hydrogens, that's going to be -2. And then let's do potassium hydroxide. All right, so we got hydrogen. I don't care about the hydrogen so much. We got sulfate, which we just said is -2. We got potassium. What's the charge of potassium? 1. It's in group 1, right? And then hydroxide? -1. That's always -1. All right. So again, these two are going to make the water. Right? So that's going to be your H2O. So these two are going to come together to make potassium sulfate. So what's the formula going to be?
Would it be SO?
Okay.
Well, I know K needs a 2.
Yeah, K needs to have a 2, because this is only a +1 and that's a -2. So you need to have 2 potassiums. K2. And then
How do I know what order to put it in?
always put the metal first. So the same order is on the periodic table. Left to right on the periodic table, left to right up here. What else? You good? Should I do another one?
No. Well, I don't know.
Oh, anybody? Yeah? No? Sure? All right, one more. Let's do HCl, hydrochloric acid, plus magnesium hydroxide. How many hydroxides go with magnesium? 2, right? It's on group, magnesium's group 2. It's 2 hydroxides. All right, the charge of the hydrogen, plus charge of the chlorine. Yeah, it's going to be -1, right? You know that because it's group 17. You also know if you just look at the acid. Look, it's only got 1 hydrogen, so this thing must be -1. Magnesium, +2. Hydroxide, -1. All right, so these are going to come together to make the water, H2O. And then, what are we going to have? What's the formula? MgCl2, magnesium chloride. All right. That's it. Good? As good as we're ever going to be for the first day before a long break? All right.